Have you ever looked up at the night sky and wondered what's really out there? The vast expanse of space is both awe-inspiring and confounding. With every passing moment, we receive data from the far reaches of the universe that we struggle to comprehend, and some of that data even suggests the possibility of alien life. Hey there, and welcome back to our channel. Today, we're talking about the Voyager missions and the exciting discoveries they made about our solar system. Despite all the advances we've made in technology, there are still many mysteries surrounding space that we haven't been able to unravel. In fact, some might agree that technology has only made space more confusing as we continue to receive vast amounts of data that we struggle to understand. And when you throw the possibility of extraterrestrial life into the mix, it's easy to see why the study of space can be so perplexing. But fear not, because, in this video, we'll be exploring some of the most mind-boggling mysteries of space and trying to make sense of the data that we do have. So sit back, relax, and prepare to be amazed. If you're new here, don't forget to hit the subscribe button and turn on notifications so you never miss a video. The Voyager missions. So, as you may know, the twin Voyager missions have been exploring space for the past 45 years, uncovering some of the greatest mysteries of our solar system. And while these missions have never meant to last this long, they have given us some of the most important and groundbreaking information about the true state of our universe. On September 5, 1977, NASA launched the first of the two spacecrafts, Voyager 1. Its primary mission was to study Jupiter and Saturn, but it was also equipped to explore interstellar space. Just a few weeks later, on August 20, 1977, NASA launched Voyager 2, which had a similar mission. Both spacecrafts were equipped with scientific instruments to study the planets they visited. Some of these equipment included cameras, spectrometers, and magnetometers. They also carried a golden record, which contains images and sounds from Earth in the hopes of communicating with extraterrestrial life upon an encounter. Voyager 1 completed its mission to study the outer planets in 1989 and is now the farthest man-made object from Earth, over 14 billion miles away. Voyager 2 visited Uranus and Neptune and is currently exploring the outer edge of the solar system. But what's truly mind-boggling is that even though Voyager 1 and 2 were launched over 40 years ago, they're still sending back data to Earth. That's right, the technology from the 70s is still sending us information from deep space. How were the Voyagers able to do more than expected? Voyager 1 and Voyager 2 were launched in the 1970s, with the original plan being a voyage to Neptune that should take 30 years. However, a groundbreaking discovery by Michael Minovich allowed the spacecraft to piggyback on the velocity of planets and slingshot further out into the solar system. Using planetary gravitation and velocity, Voyager was able to reach Jupiter in just 12 years. In 1961, the Soviet scientist Michael Minovich proposed a novel idea called gravity assist, which is also known as a slingshot effect. This idea allowed spacecraft to use the gravity of a planet to change its trajectory and accelerate to much higher speeds than would have been possible with rocket propulsion alone. In simple terms, imagine a spacecraft approaching a planet in its orbit. As the spacecraft passes the planet, it uses the planet's gravity to gain speed and change its direction. This effect is similar to a slingshot, hence the name slingshot effect. The gravity assist technique allowed the successful launch of Voyager 1 and Voyager 2 spacecrafts in the late 1970s. The spacecraft were launched on a trajectory that allowed them to visit Jupiter, Saturn, Uranus, and Neptune, and eventually leave the solar system entirely. During their missions, Voyager 1 and 2 used gravity assist from several planets to propel themselves further and further out into space. Without the use of the gravity assist technique, the Voyager would not have been able to travel as far as they did and make the groundbreaking discoveries they did, including the first close-up images of the outer planets and their moons. What the Voyagers discovered. Both probes took the very first close-up pictures of Jupiter, revealing the famous red spot Earth-sized hurricanes and even hints of water on Europa. And that was just the beginning. Soon, both probes made the trip to Saturn, giving us a better understanding of the planet's wind speeds and its 10-hour days. Voyager 1 then headed straight for the heliosphere, while Voyager 2 carried on to 2 other planets as planned. In 1989, Voyager 2 made it to Neptune, revealing the coolest planetary surface in the solar system and uncovering new data about the planet's storms and fast-moving clouds on ice. In 2012, Voyager 1 crossed the edge of the heliosphere, an invisible bubble of charged solar particles that protects every planet in our solar system from cosmic radiation. And just recently, scientists received a terrifying message from Voyager that has them all on edge. What's up with Voyager 1? Despite its groundbreaking discoveries, Voyager 1 has also faced some technical problems. One of the most significant issues was the decline in the spacecraft's power supply. The Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs, that convert the heat generated by the decay of a radioactive isotope into electrical energy. The RTGs have a half-life of about 88 years, meaning that their output declines by half every 88 years. As a result, the Voyager 1's power supply has decreased by about 4 watts per year, which has limited the spacecraft's ability to transmit data back to Earth. But this was the least of the scientists' worries: the plasma wave instrument problem. Recently, scientists received a message from Voyager 1 that left them all on edge. The message was a sign that something had gone wrong with the spacecraft, or that the spacecraft had encountered something alien. The signal was garbled and distorted, leaving researchers scratching their heads as to what exactly had happened. Upon further investigation, it was discovered that Voyager 1 had experienced a massive glitch. One of its instruments, the plasma wave system, had malfunctioned, causing the garbled signal. The plasma wave system is a critical tool used to study the properties of the solar wind, and its malfunction was a cause for concern. The failure of Voyager 1's plasma wave instrument in 1980 prevented the spacecraft from detecting certain types of plasma waves. To make matters worse, Voyager 1 was, by now, over 14 billion miles away from Earth, making it nearly impossible to troubleshoot the problem remotely. Scientists have been working tirelessly to try and diagnose the issue, but they are facing a significant challenge. The spacecraft is now so far away that it takes over 21 hours for signals to travel between it and Earth. However, the Voyager 1 team managed to develop a workaround that allowed them to continue making measurements with other instruments. They used the Low-Energy Charged Particle (LECP) instrument, which was designed to measure low-energy particles to make up for the loss of data from the plasma wave system. This allowed them to continue studying the plasma environment around the spacecraft and to detect the boundaries of the heliosphere. In addition, the team was also able to use the Cosmic Ray Subsystem (CRS) instrument to detect the effects of the glitch. They found that the instrument was able to detect a small increase in the number of high-energy cosmic rays, which was likely caused by the loss of data from the plasma wave system. Even though these workarounds proved to be successful, the glitch with the plasma wave system was still a cause for concern, as we discussed earlier. The Voyager team continued to monitor the spacecraft closely and to search for ways to fix the problem. They had made sure to share their findings and data with other scientists in the field so that they could benefit from their experiences and knowledge. However, the problem with the plasma wave system remained largely unsolved. Despite the challenge, researchers are not giving up on Voyager 1. The spacecraft has been operating for over 44 years, and it has provided us with invaluable information about the outer reaches of our solar system. Scientists remain hopeful that they will be able to restore the plasma wave system and continue to learn more about the universe around us. Other problems aboard Voyager 1. The Voyager 1 has also faced challenges due to its aging hardware and the harsh conditions of space. For example, its cosmic ray instrument has experienced some degradation, which has affected the sensitivity of high-energy particles. The cosmic ray instrument is one of the most important instruments on board Voyager 1. It is designed to measure the flux, energy, and direction of charged particles in space, including cosmic rays, which are high-energy particles that come from outside of our solar system. However, over time, the instrument has experienced some degradation, which has made it more difficult to make accurate measurements. the Voyager team has been working tirelessly to develop new techniques for calibrating the instrument and compensating for its degradation. They have also been working on developing new methods for analyzing the data collected by the instrument to ensure that it is as accurate as possible. While the degradation of the cosmic ray instrument is certainly a challenge, it is not insurmountable. The Voyager team is determined to continue making groundbreaking discoveries with the spacecraft. They are confident that they will be able to find ways to overcome any challenges that arise. Additionally, the spacecraft's propulsion system, which uses small thrusters to orient the spacecraft, has also faced some issues due to the degradation of the valves that control the flow of hydrazine fuel. The technological achievements of the Voyager missions are nothing short of astounding, especially considering they were launched over 40 years ago. The slingshot effect and gravity assist technique allowed these spacecrafts to travel further and faster than ever before, making groundbreaking discoveries along the way. However, these incredible feats of engineering and ingenuity involved in space exploration are never without their risks and challenges. Even the most sophisticated and well-designed systems can encounter unexpected, serious problems. However, as we continue to push the boundaries of what's possible in space, we must also remain vigilant in our efforts to ensure the safety and success of all who venture beyond our planet. Thank you for joining us on this journey of exploration and discovery. Don't forget to hit the subscribe button and turn on notifications so you never miss a video. Until next time, keep looking up at the stars and dreaming of what lies beyond.